Hi there. I got asked about doing a little video on my 8672A and how it actually works. So what I thought I'd do is show some of it in operation. And we'll end up taking a bit of a look as well at some of our other gear that we've got here, specifically the 8902A and the 11793. That will help us see the unit in operation. So with that, let's go through some of the functionality that's on the front panel here. What we have on this unit is a 2 gigahertz to 18 gigahertz signal generator. So it's really designed to pair with a unit like the one that I have down here, which is my 8657B. So that this goes from 100 kilohertz all the way up to 2060 megahertz, and then this goes from 2000 megahertz to 18 gigahertz. So it gives me that coverage from the pair, gives me that coverage from very low to high. Now these signal generators are fairly simple design in terms of the functionality that they have, and so most of it is a manual control on the front, but they are GPIB enabled, so we can do a bunch of control of this automatically. And in fact, I have my whole rack here, and I have all my racks actually connected up now GPIB, and I'm actually utilizing, you might be able to see it down there if we zoom in, I'm actually utilizing these 37204 HIB extenders, which are actually pretty cool because they give me an ability to run between racks, simply a coax, and then I run all the HPIB cables, just little half-meter cables up and down the individual rack. I could go to about 250 feet between racks and still have that work over 50 ohm coax. Anyway, let's go back to the unit here. These units will give you a power output from about minus 120 dB all the way up to about plus 13. And now they're broken down into certain ranges like 2 to 6 and a bit gigahertz, 6 and a bit gigahertz, 12, 12 to 18 or so. I'd have to look at the exact manual to get the ranges there. But as they go up, each of the ranges, the power output will go down a bit. And so HP offered an option where you could actually buy one that had been specifically up-leveled in the higher range and would have extra amplification there. Anyway, this one isn't one of those, but it's still a great little unit, and I've been playing around with it, and I'm very happy with my purchase here. This was the one that we repaired the 40 volt power supply on. So let's go back quickly, recap the front panel for you. We have our attenuator control, and this attenuator control will range from minus 110 dB to plus 10 dB. And this switches the main attenuator in and partners with the vernier control here to set what the actual output is. So if I had 0 dB set on the attenuator, in the little display here, the vernier will give me a range from minus 10 dB to plus 3. So it would be that 0 dB point from the primary range, and then I could go to minus 10 dB or plus 3 dBm based on how I set the vernier. So let's turn it on and take a quick look at that. And you'll see that I have this set for 0 volts here. 0 dBm. And I have it set here. And if I turn let me just go and zoom in a little bit so that we can see this, and I can turn that vernier down, and so now if I set it here at minus 5, what I'm actually getting is I'm going to get 0 dB minus the 5 dBm there, and conversely if I push this up to 3 dB I would get 3, and we'll see this just in a bit. Anyway, that's set to 0, and that will give you the actual range that you have there. So zooming out a little bit more, let's go back through some of the further controls that are over on this side. You have the ability to control the output, you have an ability to control the automatic leveling circuit or the automatic level control, the ALC. Now the ALC is basically a loop, and what it does is it looks at the power that's coming out and tries to match it to what you've set here. Now these devices can actually also use external detectors as part of that ALC control loop. And they'll do that either with a crystal detector or with a power meter, like a 438A, 437B, or an 8470B crystal detector. Now, why you might want to do that is to do things like ensure that you have a consistent level of power at a certain point in your test circuit. So you effectively extend through this input here the circuit, the loop that actually gets tested, and that way you can get a guaranteed output at the point where you need it in your test circuit. So that's pretty cool. I don't expect I'll have a lot of use for that, because what I would probably do, if I was testing something, is I would utilize a little 11667A and actually just split the signal, ramp it up a little bit, and then measure it directly on one of my power meters to get the exact power that I want. The next two items that we have over here are the modulation inputs, and you can actually put in a signal that will modulate the output, the carrier wave from this device. So you can do amplitude modulation or frequency modulation, and you have an ability with AM to set it to have a depth of either 30 or 100% based on a 1 volt peak value. So on 30, the sensitivity per volt is going to give me 30% decrease in the output. From the 100%, it'll give me 100% decrease in the output. And then I can just feed in whatever signal I want. Now that differs a little bit, because if you're familiar with signal generators like the 8657B, it has an internal modulation source. This doesn't. This requires an external modulator. Now FM does the same thing. It has an ability to modulate a certain amount of deviation on the FM based on the signal that's put in, and we'll take a look at that in a bit. So now let's move across a little bit and take a look at the other side of the instrument. Here we have our frequency reader, and we have the knob that we'll use to tune it. You notice that if I move the knob around, I'm not actually getting any frequency action. Now the reason is that these little buttons here control the resolution that you're going. So if I wanted to change the resolution down at the last digit here, I'd push that button in there, and then now I can change that resolution. If I wanted to change the resolution at the front here, I'd push the button there. And so basically I go through, and this gives me a way of saying, okay, I want to get to say 17 gigahertz. I can come up to 17, but then I want to set it to 39,500, and it gives me a way of doing that. Now it's not quite accurate here because of the way the circuit works. There's going to be some rounding off in the 1, 2, and 3 kilohertz ranges, and actually a little bit more based on where you are with the total frequency. But you can see the whole idea here is that I can go through and set different parts of the resolution spectrum and start working on that. And once I get it set, I can hit hold, and then that way, it doesn't matter if I bump the tuning dial or not. And if I need to reset it, I can hit reset. Now we have a bunch of status information here where it'll tell me if I'm using internal reference, external reference, all that sort of thing. And what I've got here is I've got the unit set up, and it's doing 3 megahertz, and it should show external reference there, but I'm not seeing that. Now I did have the cabinet out, and I was swapping some stuff around, so I might have dislodged the cable there. So let me take a quick look at that, and I'll turn the video back on shortly. So it actually looks like the external ref annunciator is out on the unit. If you have a look up here, you'll see that my 8673B is actually detecting it's running on external reference. And if you go down and look here at well, if we look at the frequency here, it's set to 3,456.789 megahertz. And if we go down and look at my frequency counter here, you'll see that it's 3,456.789 megahertz as well. And it's bouncing around a little bit on that last digit, which is sort of what you would expect. These are all locked together on my 10 meg GPS disciplined oscillator. So I'm going to have to get in there and have a look at the external reference line. Anyway, what you're actually seeing here is how easy it is to set the thing. So let's go up, and I can run this all the way up to its top frequency of 18.5 gigahertz. So it has a little bit above 18 gigahertz, but you can see that it's pulling that up there. And if I bring in the amplitude check, and let's just say step back down to 3 gigahertz here, what we're seeing is roughly minus 1.6 dB. Now, this I haven't yet, and I have to do a video on this because these are great little units, but I haven't calibrated this guy yet to make sure that the power meter is actually in spec. So take it more as a sort of an arbitrary reference point. But what I wanted to show was I can, if you see there it's minus 1.6, I can play with the vernier here, and now I'm getting very close. And if we have a look at the vernier that's up here, you'll see that I've just put over a little bit more than plus 1 0.6 extra dB out of that 0 dB range. And so that's sort of how you can get and balance some of the power there. So now what I want to actually do here now is to go and take a look at the quality of the signal. How are we going with all this stuff? So let me get this set up so that we can see the results of this on the 8902A. Alright, so we're all set up here. This is a little less than optimal because I only have the one camera and everything is sort of at a different height, and I don't have a lot of space here to be able to get the camera in and out. So I'm not going to take multiple shots. We're just going to sort of pan up and down. Let me take a quick moment to explain how the 8902A and the 11793A work. Basically, the 11793A is a microwave down converter, and what it does is it takes a local oscillator input and it mixes it with the input of the signal and comes out with an intermediate frequency. Now that frequency can be read by the 8902A because it would be less than the 1300 megahertz maximum range that the 8902A has. And so this enables me to go and measure signals up to at least, I think, 26.5 gigahertz. But seeing that this only goes to 18, that's all we need to do. Now, what they recommend is when you go and create your local oscillator frequency, that you use one that's 120.53 megahertz greater than the frequency that you're trying to read, and that will give you the most accuracy on the 8902A. So let's come up here, and you'll notice that right now I have the frequency set, but I'm not getting anything because it's well and truly outside of the range there. But if I type in 27.3 special and then 3120.53 megahertz, you'll notice now that the offsets come on, and here we go, we're reading 3000 megahertz there, and that is what I am set for this guy here. Now this is a little bit of a pain because what it means is that as I change this, I need to more or less there's a limited range that the IF frequency can be in, and so I need to make sure that they're within a certain amount of distance of each other. But now that I've got 3 megahertz there, I can go and say, okay, let's tell it that the actual manual tuning is 3000 megahertz, and I can have a look at the frequency error. And what you're seeing there is that this unit is pretty bang on. We're getting a little bit of jitter on it, but it is what it is there in terms of that that 3000 3 gigahertz frequency. So let's take this up now to say 18 gigahertz and see how we go right up there. So now we're at 18. So I need to set my local oscillator frequency for 120.5. That's clear. Let's do it again. 120.53 megahertz. So now that's my local oscillator there. And now if I come up to here and I hit frequency, you'll notice that it's still sort of weird. So I need to go in and tell it to 27.3, and then I need to say that the new local oscillator frequency is 18120.53 megahertz. Let me try this again. 27.3 special, 18120.53 megahertz. Just reset the unit. I don't know what's going on there. I think that's a 10 is, take a quick look. Input frequency out of range, so I've probably typed in something incorrect there. Alright, so now let's do 27.3 special, 120.53 megahertz. There we go. Oh, I probably had to set it back to automatic tuning or something like that. But now you can see that we're reading 18 gigahertz and pretty much just bouncing around on that last 100 sort of hertz level there. And so if I go and have a look at that frequency error and I type in 18,000 megahertz, we're getting about 1 kilohertz error there. So that's not too bad in terms of that. Let's go back to just to frequency. We'll set it to auto tuning. So now what I want to do is I want to take you through the attenuator here, and you can see that the attenuator is set to 0 dB. So on the 8902A, I'm just going to go and turn ourselves into tuned RF level, and now we'll think about it for a while, and then eventually it will give me a dB value. Now there is some amplification and stuff that goes on, and there's loss at 18 gigahertz and everything, cable loss and so on. But what I can do here is I can set this to be a 0 reference. And so now what I'm seeing is 0 dB. So now if I turn my range down to 10, minus 10, I'm getting minus 9. If I go down to say minus 50, so I get minus 50. And then if I take the vernier down to minus 10, I should get about minus 60 on the display here, and I do. And if I take it up to plus 3, I should get like minus 47, and roughly there. And so you can see how the vernier lets me play with my signal within a 13 dB range. So now that's the power level. Let's return this back to 0. Let's set everything back to 3 gigahertz, and then what I'm going to go do is I'm going to show you some of the modulation stuff. So just bear with me. All right, let's see how we go with this. what I've done is I've now connected an external signal source into the amplitude modulation, and you can see that I've turned on amplitude modulation at 30%, and I've turned the meter to AM mode, and so now the meter here is reading what the amplitude modulation is, and because it's the 30% range, so you read off the bottom here, and so it's reading 26 or so percent of modulation. So let's go up now, and on here what I can do is I can hit AM, and the unit will now go look at my 18 gigahertz signal and work out what the amplitude modulation, and you can see I'm getting about 26%. So the meter on the 8672A matches what is being detected up here. Now, I'm feeding in a 1 kilohertz modulated signal, so if I go and have a look at the AM frequency, you'll see 1 kilohertz there. And if I go in and set 400 hertz, which is another common one, you'll see we drop down to 400 hertz there. And that's at the AM level. And now if I go up and I hit 100%, you'll see we're still getting there, but now when I go back and look at that, we're getting 85%. And if we come back down here and look at our graph, then you can see across the top here that it's reading sort of closer to 90, but what I haven't done anything to calibrate or work through or tune in any of the performance adjustments on this. So out of the box, shipped from eBay, it actually has a pretty decent working amplitude modulation. Let's go throw frequency modulation in there and take another look at that. So now what you can see here is that I've turned off AM, I've moved the meter mode over to FM, hooked up FM, and I've set us up for 100 kilohertz of deviation here. And so what I'm feeding in now is 100 kilohertz signal in, and I'm feeding in at 1 volt peak, and that's sort of the sensitivity rating. And when I do that, here you see that it's driving about 100%, or about, should be 100 kilohertz. So if we go up and have a look at the 892A here and hit FM, I should see about 100 kilohertz. So what I'm getting here is roughly what I'm feeding in. So the input is working correctly there. And then if I go and have a look at the audio frequency, I'm seeing 100 kilohertz being the audio frequency that's been pushed on top of that signal. So that's the FM action part of it seems to be working perfectly well. So overall, what we've just looked at is attenuation, power, frequency stability, the frequency error. We looked at modulation, and we looked at how the modulation comes out and affects the system here. And overall, I think we've, it's shown to be a pretty reasonable condition. I should be able to tune this in and get this bang on spec. Anyway, I hope you found that interesting on the 8672A and some of the features of it. I'll catch you later. Bye.